So hello everyone, in this video we will solve a problem from IE Irodov. You can see the diagram over here. This I have not given the problem statement here. The statement basically states that we have a setup like this, the two blocks A and B. These two blocks have same mass M. This is M and this is also M. And it states that this thread PA, this is burned. Burned means this thread is, you can imagine that this thread is no longer there. So in that case, it has been asked that what will be the velocity of this block B when this block A will be lifted just above this surface. We have to calculate the velocity when this block will be, so let me construct the diagram, then probably it will be more helpful. When the block A that will be lifted, we will have a diagram like this. This is just lifted up, this height is negligible. So, and the system is also going, this block is going down, so this block, this block must go rightward, this one. So, wait, let me construct this block first. So, okay, both are M, this is M2. So now the spring will be how? This was the spring given in the question, and in this situation the spring will be quite like this, or let's draw a little more neatly. So like this, or wait, let me draw this spring. I'm having a little difficulty in this. So anyway, yes, that looks okay. So this will be the picture, okay, and so this is the case, and now we can calculate the spring constant is given at K, and in the question one more detail is given, that this K is equal to 5 mg divided by L0. L0 was the natural length of the spring. So after this we can draw the, wait, let me decrease this by a bit. Okay, so now let me construct the free body diagram of the block on the surface. This is mg, the weight, and this is K into delta L, and also let this angle be theta, okay, this is theta. So this is theta, and also there's a tension over here due to the rope, and but all over this tension is not important for solving in this case, and we can also determine this delta L. So delta L, this will be nothing but your root over of L0 square plus x square minus L0. And what is this x? X is the distance covered by the center of mass of this block, from where it was and to where it went. So this will be basically your delta L. You can also write it as L0 into L naught into cosec theta minus 1. And now if you see this free body diagram, we have one condition that, at equilibrium, when it will be just lifted, we can write this sum of force direction in y is 0, and this is x, this is y. Okay, so from this we will get that this k delta L, this into sine theta, this will be absolutely equal to mg. Okay, and what was delta L? Delta L was k L naught sec theta minus 1. So delta L we can write k L naught sin theta into cosec theta minus 1, that will be nothing but 1 minus sin theta. Okay, I am writing over the step. So 1 minus sin theta, this will be is equal to mg minus mg by KL naught. So now in the question it was given that k is equal to 5 mg by L naught. So KL naught is equal to 5 mg. So this right hand side is nothing but 1 by 5. So from here we will get that sin theta, this will be is equal to 4 by 5. So that's the first part of the problem done. Sin theta equal to 4 by 5, that was an important conclusion. Now we have to do the second part. So to do the second part, we may have two techniques actually. So we can solve by the force method, the method of kinematics, not exactly the force method. We can use kinematics, and in the second method we can use the conservation of energy. So here I will solve by both the methods, though the energy method is way more effective, but just to improve your concept of kinematics, I will use both methods here. Okay, so just let me solve by the method of, let me just write force conservation is not a thing, but so what can we do with the header? Let's say kinematic solution. That looks a little iconic too. Anyways, kinematic method. Okay, so here what we have here, we had that sin theta is equal to 4 by 5. Now what can we comment on the force? Look, these two blocks here, this whole is a system. So this whole is a system, right? This is a system and we have forces on the system. So there are internal forces, of course there are, but in this method we will treat that this is a system, and for this block we have gravity acting like this. This is mg, and now let's solve this. So let A be the net acceleration of the system. So we may write that total mass, which is 2m, that multiplied by A into, let's write this as a function of x. So this will be, we have mg for the lower block. So we are writing for the system which I just marked in the picture. So this is mg minus minus we have to consider the horizontal component of the spring force, which is K delta L, which is only K delta L cosine of theta. Now, as a function of time, this will be mg minus K into root over L naught square plus x square minus L naught. And what will be cos theta? Cos theta will be nothing but equal to x divided by root over of L naught square plus x square. Okay. So, and now sorry for the, so anyway, and we can write that wait a little, now that's okay. So this is mg minus K into x into 1 minus L naught divided by this term L naught square divided by L plus x square. Okay, so that's basically our 2m into ax. So from here we can write, now this is the one of the important steps, a of x, this will be, we can take half to be common, this will be half into g minus kx by m into 1 minus L naught divided by L naught square plus x square. Okay, so this method, you can see that it's a little lengthy, and now yes, you guessed it, we have to use integration now. So anyway, let's do it. You know that v into dv dx this gives acceleration. So v into dv, this will be a dx, and now we can put the limits and integrate. Let the velocity of the second block be v naught at the time when the contact goes off. So integration, it starts from 0, v naught v dv, and also we, now what will be the limit for x? The lower limit is 0, no doubt about that, but what will be the upper limit? Now we had calculated theta, sin theta was 4 by 5, so your cos theta will be 3 by 5, and that will also give that x, which was the base, so base will be 3 by 5 into L naught, so that will be basically our limit, I mean the limit of x. Okay, no, I am sorry, I mean x will be 3 by 5 into L naught square plus x square. Now if we calculate the tan theta, we will get that tan theta is equal to 4 by 3, and tan theta is basically L naught by x, so x is equal to 3 L naught by 4, and that will be our upper limit. This is the x where the contact goes off, I mean for the block on the surface. So we can write that v naught square divided by 2 into, we can take the half in common in there, and the halves will get cancelled, 3 L naught by 4, this will be g minus kx by m, so 1 minus L naught by root L naught square plus x square dx. So if we take the half, if we eliminate the half, so this will be V0 square, that will be is equal to G into, that will be integration of dx, so only 3 by 4 into GL0, only that will survive. And after that kx by m, so we have the integration of x dx, and so that is x square by 2, so it will be 9L0 square by 16, but there is a 2 factor, so it will be 9L0 square by 32, and there is k by m, so 9KL0 square divided by 32m, that will be the second. And now I will actually have to do this part. It's not, I am not able to solve it orally like the previous two terms. And this is what, oh okay, firstly let's take the constant terms out. Constant terms are what? KL0 by m, this is 0, 3L0 by 4, and here we'll have x divided by, this is basically our integration which we have to do into dx. Now if we sum this up, the previous two parts, this is 3 by 4 GL0, and also this part it was given that KL0 equal to 5 mg or k equal to 5 mg by L0, so we can write this as 45 by 32 GL0, and if you calculate this integral, this will come out to be L0 by 4. So you can calculate let this low function under root L0 square plus x square equal to y, and then you will get the limits and everything. This x dx, there will be a 2 here outside. You know, right, how to integrate functions. So this is basic integration. Okay, so this is plus, I am directly writing, this is KL0 square by 4m, and KL0 square by 4m, that will be basically what? This is 5, so 5, this will be 5 by 4 GL0, so we have almost obtained our answer. 3 by 4 minus 45 by 32, so this will be 5 by 4 into GL0. Just note the point if you haven't still noted. That's the only thing I fear, that k is equal to 5 mg by L0, and this was given in question. Okay, in case you missed. So if you calculate, this comes out to be 19 by 32 GL0, and for the final answer, wait a minute, GL0, and for the final answer, that is basically the root of this. So the velocity of the lower block when the upper block, the block on the surface, loses contact with the surface, let me write here, that will be basically the root of this. So that's your answer. Okay, by the way, that's not the end of the video though, because that's only method 1. We have one more method to go, and this was the lengthy method. You can see how lengthy it was. So now we will have a shorter approach, and that will be nothing but your energy, wait a minute, in this method we will just conserve energy. That's okay. Energy conservation method. So that's our second and more efficient way to work this problem out. Okay, so let's begin with this. So here we can solve this problem with exactly one equation. I mean nothing more needed. So in this problem we'll just in this method we'll just balance the, we'll write the force equation, right? So no, sorry, not force equation but energy conservation. So what was the initial energy? What conversion is made here? You have V0 velocity at the end, so both the blocks have that velocity because it is one single system. So I may write that 2 into half 2 into half 2 into half mv0 square, that is the kinetic energy, and from what it is supplied to, plus the spring has a potential energy which will be half into k delta L squared, and that will be equal to what? What has given rise to this energy? You may observe that this is more accurately I am writing Work-Energy Theorem. Why? Because that is the total change of energy here. This is delta E. So let me just write that for your convenience. This is delta E, and we have a work done here. What work is done? You may see that this block, the block on the upper side, this has moved, right? This is going here, so it has gone x distance. So and the force is also here, parallel. So work has been done, and clearly the work is mgx, because G is the force pulling the block. So more accurately it will be T into x, but T is equal to mg, as you can solve by force balance for the block block hanging. So this is basically your W, and what I have written, this is nothing but Work-Energy Theorem. This is nothing but Work-Energy Theorem. Okay. So now we have just one equation and we'll get the answer. That's the efficiency of energy conservation. In this method you have to do all this stuff, and at last we have to do some kinematic stuff. Then we finally got this answer. But in this method, you may already see that it is way more efficient. So from here you can write that this is mv0 square plus half k delta L, and as always delta L is nothing but that thing. So k into root over L0 square plus x square minus L0, and this squared. this square is equal to mgx. And here what is x? So at this moment x will be is equal to 3L naught by 4, as we had that sin theta is equal to 4 by 5, that will give us tan theta is equal to 4 by 3. So L naught by x equal to 4 by 3 and x equal to 3 by 4 into L naught. So let's proceed. mv naught square plus half into so this is x is 3 by 4, so this whole term, this will be 5 by 4 L naught minus L naught. So L naught by 4 this square is equal to mg 3L naught by 4. Okay, so we are almost done now. So mv naught square plus 1 by 32 KL naught square, this will be is equal to 3 by 4 mgl naught, and as I said earlier that KL naught is equal to 5 mg, so let's take that over that side. So it will be 3 by 4 mgl naught minus 5 by 32 mgl naught. Let all the m's cancel, so you will only have that v naught square is equal to, if you subtract 3 by 4 from 5 by 32 from 3 by 4, this 3 by 4, this is basically 24 by 32, this is 5 by 32, so you get the same answer, 19 by 32 into GL naught. Okay, so let me write the final answer from this method here. I mean, they both are the same obviously, but for a good looking note, let me write like that. This is GL naught, and again that is our final answer. That's the velocity of the block B when this block A just loses contact with this surface. Okay, so that's basically your V naught, that is 19 root 19 by 32 GL naught. So this was the whole problem, and it was I will agree that it was a very nice problem from Irodov. Actually, if you if you are a little good in physics or little interested in physics, then Irodov should not be tough for you at all. But there are obviously some nice problems, some college level, even some A level, MSc level problems. But this one, I mean, I will definitely agree that this was a very nice problem, and I mean, this something like this may appear in JEE Advanced. You have no idea. So that might happen any day. So with that in mind, I sign off here, and thank you for watching. And just I hope you learn both the methods. I hope that both the methods, I believe I was helpful in teaching you both this method. The concepts of both these were strengthened in your mind, and I hope you will be able to do well in these types of problems from now. So for now, that's the end of this video. I sign off here, and bye bye. We'll see you in the next video. Bye.